This video will show you how to find the roots of a quadratic function when it's already in standard form. Remember that standard form means that you have no parentheses, that you have a, b, and c values. And remember that finding the roots means we're looking for an answer where you have x equals. And usually for a quadratic function, we're going to have two roots, x equals, x equals. Well, if you think about what a root is, these answers that we expect to get at the end, they're really two numbers that you can plug into this function to make it equal 0. So the first step is to think of this as an equation, not a function, and the equation is just 2x squared plus 3x minus 20 equals 0. In order to get x by itself, we have two options. We could use the quadratic formula, or we could factor. In general, if factoring is possible, that's going to be the easier option. And so I'm going to try to use the snowflake method in order to put this in factored form. When I do that, I fill in my snowflake, and we get a times c is negative 40 at the top and positive 3 at the bottom. Two numbers that multiply to equal negative 40 and add to positive 3 are positive 8 and negative 5. And the fact that I could find those numbers means that it is possible to factor this expression. If you need more help on the snowflake method, you should pause here and go back to the last section, which has a video on factoring. Otherwise, we'll continue, and we continue by writing factored form of this quadratic, which is going to be 2x minus 5 times, and be careful here because you have to simplify, x plus 4 is going to be your other factor, and that's because we simplify that expression to 1 over 4. Once you have factored form of a quadratic, finding the roots is pretty easy because the zero product property tells us that we just need to split and then solve. Splitting this out, we have two equations to solve. X plus 4 equals 0, and 2x minus 5 equals 0. If I subtract 4 on both sides, this equation gives me x equals negative 4 as a solution. And this equation, add 5 to both sides, then divide by 2, which leaves me with x equals 5 over 2. And these two numbers are my roots, which I can fill in down here as my answers. In a minute, I'll give you a couple to practice yourself, but let's take a look at one where factoring doesn't work. With this second example, if I were to try the snowflake method in order to write it in factored form, I would end up with a times c being positive 10 and b equaling negative 8. And when I try to find two numbers that multiply to 10 and add to negative 8, it's actually not possible. So what that means is I have to use the quadratic formula. In order to do that, of course, you need to know what a, b, and c are. And then you're also going to definitely need to know the formula itself, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a. For this quadratic, 2 is my a value because it's the coefficient of x squared, negative 8 is b, and positive 5 is c. When I plug into the quadratic formula, I like to do it in 4 pieces. The things to be careful about are this negative inside the square root and that you square the b correctly. Here's what it'll look like. Negative b flips the 8 to a positive 8, and then we get plus or minus the square root of 64 minus 4 times 2 times 5, which is 40. And then that goes all over 2 times 2, which is 4. And from here, the rest is just simplifying. So we start with the part inside the square root. And inside the square root, we have the number 24 from subtracting. And 24 doesn't have a perfect square root, which means that I can't completely get rid of that symbol. But I can partially get rid of it because I can rewrite 24, and I can think of it as the multiplication problem 4 times 6. The reason that's useful is because 4 is a perfect square. So the square root of 24 can be simplified to equal 2 times the square root of 6. And 2 comes out because that's the square root of 4. From here, there's a couple different things that you could do first. What I would recommend is I would split this expression into two fractions because the 4 on the bottom belongs to both the 8 and the 2 root 6. And so if I split that into two fractions, we get 8 over 4 plus or minus 2 root 6 over 4. And the reason that's helpful is because now we can simplify 8 over 4. That's the same thing as 2. And 2 over 4 is 1/2, which means I'm going to write the second part as root 6 over 2. And you could put a 1 up here because 1/2 is really where we're getting that number from, but normally we don't write it out front. The last thing that you have to be careful with is this plus or minus symbol is telling you that there's actually two answers here, and the best thing to do would be to split them out so you can see really clearly that we do have two roots. The first one is 2 plus root 6 over 2, and the second one is 2 minus root 6 over 2. The one thing that I think a lot of people struggle with is this last simplifying step. So let me show you a couple tips for simplifying before I give you your own problems to do. The first thing that I'll remind you is that you need to make sure that you watch out for negatives in perfect squares. In this first example at the top, this is something that you might encounter sort of at the end of a quadratic formula problem. And you simplify it just like we did, except that that negative right there indicates to you that you will have an imaginary number in your answer, because you know that you can't take the square root of a negative number without getting an I. And that turns into an I. The 18, if we were going to simplify that, we know that 18 is 9 times 2, and the square root of 9 is 3. So 18 is the same thing as 3 root 2, and again the I comes from the negative. From here, I'll split it into two pieces, and I'll actually simplify as I go. So 6 over 3 is the same thing as 2, and 3 over 3 is the same thing as 1, so that cancels out, leaving root 2 and I at the back. And then the plus or minus, of course, you always split it out to remember that there are actually two answers written here, 2 plus root 2I and 2 minus root 2I. The last kind of careful thing you need to be watching for is sometimes if you have a perfect square underneath the square root, it actually disappears altogether. So in this case, the square root of 36 is 6, and because it's a perfect square, there's no more radical symbol, which means that when I go forward, actually instead of splitting into two pieces, you should just go ahead and do those simplifications on the top. This is the same thing as 2 plus 6 over 4, and 2 plus 6 is 8, and 8 over 4 is just 2. So that gives you a normal looking answer of x equals 2. And then the second answer would be 2 minus 6 over 4. And that should be a positive 2. That was a mistake there. So 2 minus 6 is negative 4, and negative 4 over 4 is negative 1, which would be your second answer. If you get a perfect square in the square root, it probably means that you could have used the factoring method, but you don't have to as long as you're careful about your final answers. Here's the first one for you, and you should pause the video while you solve it, and when you press play again, I'll show you the answers. Here's the answer for the first practice problem. This is one that you definitely could have factored. However, if you use the quadratic formula instead, you still will end up with the right answer. If you want more time to look at this, pause the video here. Otherwise, let's do another practice problem. Here's your second example. Pause the video while you solve this one, and then press play when you're ready for the answers. Here are the answers. And here's your next practice problem.